discussing Oumuamua, is that what I
Yes,
said?
that's the right.
Oumuamua, which is an object that we detected in space that you believe could possibly have been extraterrestrial in origin, meaning from some sort of a civilization.
Oumuamua, the mysterious interstellar object whose peculiar orbits captured the attention of observers in late 2017, is making headlines once more. But this time, scientists are afraid. Oumuamua is scheduled to make a direct collision with Earth in only 2 weeks, an unprecedented occurrence. This cosmic event is especially disturbing because, in addition to the imminent collision, Oumuamua appears to be traveling at an alarming speed. Are we on the verge of a catastrophe? Come explore the serious warning that scientists have issued regarding Oumuamua's direct effect on our world. Upon hearing the words alien probes, what first springs to mind? Maybe it brings to mind classic science fiction films with aliens examining people with weird devices. Alternatively, perhaps you see Oumuamua, the enigmatic, cigar-shaped object that streaked by our solar system a few years ago. In 2017, researchers like Harvard University's Avi Loeb began discussing the potential of actual space probes launched by far-off civilizations, as opposed to the fictitious sort. These spacecraft would resemble the ones that humans have launched into orbit, such Voyager and New Horizons. The crucial query is Oumuamua a comparable probe, albeit one that hails from a different planet? Plasma physicist Avi Loeb has even hypothesized that Oumuamua itself may have been an extraterrestrial spaceship. Although that theory may seem improbable, scientists are really excited about it. But there are significant obstacles. To begin with, the distances in space are astounding. A probe sent by extraterrestrials from the Andromeda Galaxy would have to traverse an astounding 2.5 million light-years, or 6 trillion miles, to reach Earth. Then there's the issue of time. How will they ensure that their probe arrives here prior to the fall of their civilization? However, assuming they resolve those issues. Even so, they would still need to construct a probe robust enough to endure all of the hostile environments found in space, including radiation and space debris. Imagine constructing something incredibly robust and resilient, perhaps made of a substance that is as hard as a diamond but can withstand impact without shattering. Scientists were ecstatic when Oumuamua arrived in 2017 despite the difficulties. They had been hoping for an interstellar visitor just like it for decades. Who knows? We could find out eventually that we're not the only ones in the cosmos. An exciting finding was made back in 2017 by NASA's Science Associate Administrator Thomas Zurbuchen, the confirmation of interstellar objects like Oumuamua. Astronomers all across the world became quite interested in this finding. Then, in August 2019, a mere 2 years later, 2I/Borisov, another interstellar object, was discovered. Borisov, in contrast to Oumuamua, possessed the characteristic comet characteristics, such as a prominent tail and coma. Astronomers were given a unique view into extraterrestrial planetary systems by this enigmatic guest. When first observed, it seemed like a massive cylinder that was 10 times longer than it was broad. However, further observations showed that its shape was more like a pancake. Occurrences of comparable forms in other Kuiper Belt objects point to a shared formation process. Astronomers were able to determine Oumuamua's size and form by observing its brightness as it traveled through space. It's interesting to note that Oumuamua's trip can be linked to 4 probable near encounters, the closest of which was with the red dwarf star HIP 3757. After this discovery, scientists began to question where Oumuamua came from and if it had been floating through space for millions of years with an unknown origin. Stellar bodies such as comets, asteroids, and planets circle the sun in close orbits, like a busy neighborhood. However, something remarkable occurred in 2017. Oumuamua, a strange visitor, arrived in our cosmic neighborhood. Its course was not a tidy circle like the others. Rather, it was hyperbolic, speeding past the sun at such a high rate that it was little impacted by its gravity. It resembled a cosmic projectile speeding across space. On October 19, 2017, University of Hawaii astronomer Rob Warrick made the first observation of Oumuamua. It was already 21 million miles from Earth at that point, and it traveled as near to 15 million miles before departing from our solar system. With a push from the sun's gravity, this intergalactic visitor was traveling at an astounding 54.2 kilometers per second. But it was not an easy endeavor to get a peek of Oumuamua. It was little and swift, allowing us only a few weeks to do in-depth research on it. Fortunately, several amazing photos were taken by the Hubble Space Telescope and other strong observatories, showing Oumuamua as a tiny dot in the expanse of space. Oumuamua accelerates out toward the constellation Pegasus and then vanishes from our line of sight, vanishing into the frigid Kuiper Belt, which is the region beyond Neptune. But would it come back? And just who or what was Oumuamua? Some believe it is simply a dead comet that has been stripped of its gases over billions of years, while others believe it to be an extraterrestrial probe. There's no denying that Oumuamua's brief visit has captured the attention of scientists and space enthusiasts alike, igniting discussions and piquing our interest about the secrets of space. Oumuamua's voyage was not without its difficulties, though. When the Hubble Space Telescope descended from the Sun, it saw an odd acceleration that was not caused by gravity. Usually, comets release dust and water vapor, which gives them a tail to propel them forward. However, Oumuamua showed no indications of leaking water or other volatile materials that are frequently observed in comets. What then may Oumuamua be? Unlocking the secrets of Oumuamua, according to a common idea, it's a piece of nitrogen ice. Researchers Alan Jackson and Stephen Desch of Arizona State University speculate that Oumuamua might be a piece that was blasted off of a Pluto-like planet by a powerful impact. The additional boost would have been present if the nitrogen ice had melted as a result of the sun's heat. But for Oumuamua to appear as pale as it did, it would have to be smaller than first believed. According to a different idea, hydrogen gas locked in water molecules was released by cosmic rays reacting with surface ice in interstellar space, resulting in a supply of hydrogen gas trapped in amorphous water ice. This proposal, put forth by Jennifer Bergner of Berkeley University and Daryl Seligman of Cornell University, contends that Oumuamua moved ahead because the sun warmed it, causing hydrogen to escape and changing the ice's crystal structure. Furthermore, two very intriguing theories have been put forth by Harvard University astronomers Avi Loeb and Shmuel Bialy. Oumuamua may be a solar-powered spaceship. They suggested the potential of alien technology at work by suggesting that the many abnormalities noted in this interstellar visitor may be properly explained by an artificial origin. Oumuamua's route indicates that it came from somewhere beyond of our solar system. But since we were unable to get a close-up of this visitor, its actual dimensions are still unknown. To determine its size, astronomers use its brightness and their understanding of how comets and asteroids reflect light. The comet idea is questioned by several scientists since Oumuamua has not been detected to have a coma or tail. Oumuamua's rotation period would also be altered by outgassing, a comet's characteristic feature that hasn't been seen. Repeated non-gravitational acceleration refutes the scientists' theory that Oumuamua's apparent movement originated from the force that separated it from its parent object. Alternatively, there's the intriguing hypothesis about sunshine. If Oumuamua is very thin, between 0.3 and 0.9 millimeters thick, then solar radiation pressure may be the cause of its reported movement. They hypothesized that Oumuamua may be a light sail, a technique proven on space missions such as NASA's NanoSail D2 and the Japanese Icaros probe. These light sails travel across space by harnessing the kinetic energy of photons. According to the estimates, Oumuamua might make it through interstellar space on a light sail for a considerable amount of time. Its estimated distance from its parent system, wherever it may be, is at least 16,000 light-years. We take seriously the possibility that Oumuamua is space junk or an extraterrestrial ship. It may have come to Earth by mistake, or it may be a deliberately launched spaceship studying our solar system. The peculiar discovery method of Oumuamua lends credence to these theories. Finding it as we did suggests that every star in the Milky Way ejects a huge number of such things over its lifespan, if it is a member of a random population of objects. That being said, there aren't as many things like Oumuamua in our solar system. It is also difficult to pinpoint Oumuamua's origin because of its motions near alignment with the local standard of rest, a region of the Milky Way galaxy. Oumuamua is traveling towards the outer solar system and will be too fast for conventional rockets to catch up with. Though initiatives like Breakthrough Starshot attempt to send small robotic probes with sails hurtling towards it at great speeds, this may not be possible in the near future. Whether we get it to Oumuamua, learning about its visit can help us get ready for further interactions. Astronomers can study other fascinating things that are now in view more effectively by making detailed observations and using the knowledge gained from this experience. More thought and planning would be necessary if the Oumuamua space probe returned. If we contemplate the possibility of something remarkable occurring, might we think about constructing a shipyard here in Karelian territory? We should. Consider what actions to take in the event that the asteroid space probe returns. In order to build spacecraft that can go after it, humans must have a better knowledge of dark energy in the universe. Sending a vessel after the asteroid probe is one idea, but it will be extremely difficult. Oumuamua will pass beyond Saturn's orbit in 2 years because to its hyperbolic excess velocity of $5.50 per year. This is the fastest item that humans have ever launched into space. What sort of vessel would we then require? And should we utilize solar sails or something more exotic like a wormhole for propulsion? Wormholes are a fascinating idea, but there are a lot of problems with it, such as collapse, connections to other worlds, and ignorance about how they are built. Cosmic gateways and interstellar travel in 1935, Nathan Rosen and Albert Einstein presented the intriguing idea of wormholes in the context of general relativity. Einstein-Rosen bridges, or wormholes, as they were known, are hypothetical passageways that connect various locations in spacetime. These wormholes could produce shortcuts that shorten the amount of time and space needed to travel through the cosmos. Despite the likelihood of wormholes being implied by Einstein's equations, none have been seen or verified as of yet. It is difficult to confirm the existence of wormholes connected to black holes, despite some equations suggesting their existence. It is difficult to know if objects or people falling into black holes will survive or not, hence it is impossible to know if they will link to wormholes. Einstein's theory of spacetime, which he saw as a fabric encircling the whole cosmos, forms the foundation of this idea. According to Einstein, this fabric is warped by the interplay of mass and energy, resulting in valleys that affect how planets and stars move. Rather than a direct force of gravity, gravitational impacts are the result of this manipulation of spacetime. According to Einstein's theories, spacetime might be further altered, even split, leading to the creation of the concept of wormholes. The idea is that something would have to be on the opposite side of spacetime if a hole were to open up. Unexpectedly, a variety of wormhole forms have been suggested by Einstein and other scientists. Classified according to its characteristics, traversable wormholes are the most well-known and frequently featured in science fiction. Similar to the wormhole in Star Trek Deep Space Nine, they act as bridges connecting various places in the cosmos and allow travel between them. It is not possible to travel via non-traversable wormholes. They might not have an escape route, so everything that enters is trapped, or they might collapse before anything can pass through. Wormhole research continues to be an intriguing field of study, combining theoretical physics with creative potential. Though mostly theoretical, the idea nonetheless piques scientists' curiosity and serves as an inspiration for literary and cinematic works. One-way wormholes are a notion that implies you can go through one end of a wormhole but require another wormhole to return. It's interesting to note that while they are unpassable, certain of Einstein's equations imply that wormholes might exist within black holes. In contrast, white holes expel stuff with enormous power, making them the opposite of black holes. Two-way wormholes are the next in line. These wormholes facilitate round-trip travel by allowing for back-and-forth movement. Wormholes that connect various places in our universe are known as inter-universe wormholes. Conversely, inter-universe wormholes link our realm to a parallel one. Consider them as the crisis wormholes that lead to parallel realms if you enjoy Marvel or DC comics. The crucial query at hand is, in our universe, where are these wormholes located? In theory, they may reside in white holes, black holes, and other large celestial entities. But for now, they are still mostly theoretical. In the scientific community, this kind of ambiguity is not unusual. Something does not always exist just because it is theoretically feasible. It's comparable to the riddles surrounding dark matter and dark energy, which are hypotheses based on mathematics, but not yet completely confirmed. Speaking of theories, the existence of wormholes is firmly supported mathematically by Einstein's theory of general relativity. But it's important to keep in mind that theories, no matter how solidly supported they are still open to interpretation and more research. Therefore, even if we may imagine and conjecture about wormholes, their enigmatic nature serves as a reminder that there is still a great deal we don't know about the enormous universe. Maybe someday, in the ideal conditions, we'll solve the riddle of these cosmic shortcuts. The pursuit of knowledge goes on till then. Envision a whole new explanation for why wormholes haven't been found yet. These cosmic shortcuts are like fissures in spacetime, according to Einstein's hypothesis. Still, it's possible that nothing in the cosmos has been able to sever this thread. It hasn't occurred yet, but it's not impossible either. It's interesting to note that some science fiction programs and motion pictures have astronauts blowing apart spacetime to create their own wormholes. It might be that we have to make our own wormholes because we haven't discovered any naturally occurring ones. Alternatively, it's possible that these wormholes are already there in space and we haven't discovered them yet. You could ask, but how could we miss a wormhole in space? Well, think about how big space is, trillions of light years across. We can only witness a tiny percentage of it with any regularity, despite our best attempts to investigate it. Even though we can see planets and stars in far-off galaxies, we are continually finding new moons in our own solar system. Given our limited capacity to explore space, it makes sense that certain things escape our notice. Why don't wormholes exist? The Big Bang hypothesis, which postulates that the universe started with a massive explosion that dispersed matter in all directions, provides the most likely explanation. This stuff combined over countless millions and billions of years to create the cosmos we know today. But this violent incident probably made a lot of holes in spacetime. Some others speculate that cosmic strings connect these holes, creating a network of wormholes that is just waiting to be discovered. Let us now contemplate the size of the cosmos. Uncovering the mysteries of wormholes, if the universe consisted of only 5 wormholes, dispersed randomly and possessing both entrance and exit sites, how likely is it that one will come close to our location? Would we even be able to identify it? Is it something we could find in all of space? These inquiries illustrate the difficulty in discovering wormholes and the enigmatic character of the cosmos. Think about Star Trek for a minute. Wormholes in the episode were only noticeable when someone got close to them. It was uncommon to come across a stable wormhole, such as the one in Star Trek: The Next Generation, that collapsed after a ship entered it, trapping the crew far away. That's why the wormhole close to Deep Space Nine was so special. Therefore, it's possible that the reason we haven't discovered a wormhole yet is only that we haven't looked for one yet. Oh, and here's an intriguing theory. Some scientists speculate that wormholes, rather than black holes, may be located in the cores of galaxies. If accurate, it would imply that the cosmic strings I previously suggested bind all galaxies together, which would be quite amazing. Let's consider another query now. Could a wormhole exist in a vacuum if it were real? Now, let's pause to consider gravity. In our minds, wormholes are gaps in space that link various locations. However, one factor in the cosmos that probably opposes such a thing is gravity. Thus, if wormholes existed, gravity's pull would force the cosmos to attempt to seal them shut. Consider black holes as an example. While some are able to withstand this force and endure, others are destroyed by things like Hawking radiation. This implies that, if wormholes were formed at the Big Bang, the forces acting on the cosmos may have caused them to collapse over time. Nonetheless, the persistence of certain wormholes may be due to the cosmic strings that we previously discussed. Though this is merely speculation, these threads may supply the matter or energy required to maintain them open. There were limits even to the powerful Star Trek warp engines. This is the reason why everyone wanted control over a stable wormhole. If only from a scientific perspective, picture yourself having the entire cosmos at your fingertips. It's really alluring, particularly for investigating far-off galaxies that we would never be able to visit in person. Now, though, let's make it more relatable. We could make history by being the first humans to travel across the stars if we could build our own wormholes. Humanity is presently working toward this objective by sending expeditions to Mars. Imagine, however, that you launch into space, create a wormhole that is little larger than Earth's gravity, and then you arrive on Mars right away. Consider how this may hasten the process of colonizing Mars while saving an enormous amount of resources. If it could be done for Mars, it might also be done for other planets, such as Titan, the moon of Saturn, or even Alpha Centauri, which is frequently considered a possible destination for human habitation. A wormhole is analogous to a space traveler's cheat code. We would only need ships strong enough to withstand the trip through the wormhole, not ones that could go to far-off areas in a certain amount of time. Although it's an intriguing idea, it's still only a dream for the time being. However, it's a dream that excites and piques the interest of scientists and science fiction fans alike. Building a launch pad beyond the outside of the asteroid belt is a fascinating idea, given how difficult it is to comprehend and operate wormholes. This concept is similar to the allo drive, a suggestion made by Freeman Dyson. This allo drive would mimic traveling through an airport on a moving conveyor belt. The warp bubble is a further idea in which space-time bends around the spacecraft to give the impression that it is propulsion. But there are several obstacles in the way of building a warp engine, such as the requirement for negative mass, which is still unknown in space. It's astounding to think that something as massive as Jupiter would be needed to power a spacecraft the size of a car. The question of how humanity may have used such a powerful force only serves to heighten the curiosity around Oumuamua's and 2I/Borisov's rapid motions. Photographs of 2I/Borisov taken by the Hubble Space Telescope provide new insights about the object. Scientists were able to determine its identity and differences from Oumuamua thanks to these photographs. Undoubtedly, 2I/Borisov, akin to Oumuamua, is unique in that it originates from beyond our solar system. However, its origins and the lessons it might impart on our understanding of the larger world both captivate scientists. It's amazing that this comet has characteristics that are similar to the materials that made up our solar system, even though other star systems may be different from ours, said Amaya Morrow-Martin of the Space Telescope Science Institute. Its quick movements contribute to its attraction. With its incredible speed of 110,000 miles per hour and its hyperbolic orbit around the Sun, Borisov is not expected to stay in this location for very long. It is not going to be slowed down by the gravity of the Sun, unlike most things in our solar system. Based on its speed, astronomers calculated that Borisov would zoom past Jupiter and disappear into space, never to be seen again. NASA and other space organizations now have a limited amount of time to learn more about its makeup and behavior before it ends its life. One other observer, Max Muchler, pointed out that new comets can be quite unpredictable. The space teams around the world are working hard to secure more observation time to learn more about 2I/Borisov before its brief visit ends. They may suddenly brighten or even break apart when exposed to the sun's intense heat for the first time. Hubble stands ready to monitor whatever unfolds next with its advanced sensitivity and resolution. We already know certain details regarding the nature of 2I/Borisov, but scientists are eager to learn more in the upcoming months or years. Yes, we have determined that it is a comet, a crucial finding that contributes to the whole description of this intergalactic Voyager. Its coma is a crucial sign of its cometary nature. For those who do not know, the comet's hazy cloud that surrounds it while it is in space is called the coma. When the heat from a nearby star interacts with the stony core of the comet, it partially melts and releases gas and dust, which is what causes this fuzziness. More difficult to determine has been the comet's size. Estimates of its size have changed along its trip through space depending on the observation equipment employed. Nonetheless, current calculations indicate that the comet's nucleus has a diameter of between 1.4 and 6.6 kilometers, which is fairly large. 2I/Borisov is essentially a comet that acts like any other comet in the cosmos, with the exception that it is speeding through star systems and occurred to pass near our own. Oumuamua was distinguished by its special qualities. It lacked the tail and coma that are typical of comets. Astronomers were perplexed by Oumuamua's peculiar appearance, even though predictions regarding the presence of interstellar objects before its discovery. Some speculated that it may be outgassing, perhaps from sublimation of nitrogen or hydrogen ice from another solar system. However, other experts contend that this may be similar to the New Horizons and Voyager spacecraft, but coming from a different planet. August and September of 1977, 40 years ago, saw the launch of 2 robots by humans on an amazing mission to investigate the immensity of space outside our solar system. The twin Voyager spacecraft set out on their historic journey by taking advantage of a unique planet alignment. They shot out in a straight line toward Jupiter, using its powerful gravity to propel them toward Saturn. They took different ways at Saturn. Steering skyward, Voyager 1 headed into the uncharted territory of interstellar space. As all of this was going on, Voyager 2 kept traveling, tracing a circuitous path through the outer planets toward Neptune and Uranus. The hazy dot in the distance became vibrant worlds at each meeting, providing deep insights into the secrets of the universe. Amazing photos of Jupiter's intricate jet streams were taken by Voyager, showing whirling patterns inside patterns. It saw the strange sight of the volcanic eruptions on Io, a gravitationally distorted moon, and the mysterious frozen surface of Europa hiding an ocean beneath it. The gem of our solar system, Saturn, was reached by the Voyagers 2 years later. Once thought to be a smooth band, its magnificent rings now showed minute grooves and moonlets circling its edges. Entering Titan's methane-filled atmosphere, Voyager saw the mysterious Iapetus, whose sides alternated between bright and dark like a yin and yang in heaven. Voyager 2 continued ahead, as Voyager 1 said goodbye to Saturn and headed into the cosmos. It came across Uranus, a strange planet with a tilt of around 90 degrees, which had weak rings and a captivating blue-green color. It then passed Neptune, a calm planet with turbulent cyclones around its atmosphere. In the meantime, antennae on Earth struggled to pick up the sporadic signals coming from Voyager, which was now over 3 billion miles distant. The biggest moon of Neptune, Triton, was Voyager 2's penultimate stop. Amid its ice terrain, the moon was dotted with black nitrogen geysers. Voyager's incredible journey came to an end with Triton, adding another cosmic wonder to its impressive collection. Beyond simple observation, the Voyager mission served as a cosmic message. Like a time capsule from the 1970s, each spaceship carried a unique message in the shape of a gold record that contained the essence of Earth's sights and sounds and came with a needle and playback instructions. Humanity's greetings, conveying our wish for friendship and peace as we traveled into the uncharted regions of the cosmos, were etched onto this golden disc. These tapes and these photos were meant to live longer than our planet itself, circling across the great void of space like fingerprints on gold. Voyager 1 directed its cameras back towards home as it said goodbye to our planetary neighbors, creating a famous family portrait of our planetary siblings. Carl Sagan is well known for referring to Earth as a pale blue, a symbol of our little position in the vast cosmos as a speck of light amidst the grandeur. No other spacecraft has been as far or seen as many marvels as this one. In the far future, the Voyagers could come across another civilization, but by then, mankind might already be extinct. Nevertheless, the echoes of human presence will be carried by these quiet sentinels on their endless journey across space. Their peaceful voyage is a moving reminder that once upon a time, we wandered among the stars, bringing with us a heritage of inquiry and discovery. NASA's New Horizons spacecraft set off on an amazing trip to the far-off planet Pluto in January 2006. The first item created by humans to approach the cold dwarf planet was this amazing spaceship. However, its goals went beyond that. It sought to go even beyond, exploring the cryptic Ultima Thule object that waited to be discovered in the enigmatic Kuiper belt. In order to complete its mission and reach the furthest regions of our solar system, New Horizons has to cross the hazardous asteroid belt. This area, which lies between Mars and Jupiter's orbits, is not just a barren wasteland, rather, it is teeming with many rocky bodies, like a kind of cosmic highway. Among these space travelers, in June 2006 New Horizons came into contact with 1325248PL, a tiny yet important asteroid. Even though it could only look like a blur from a distance, this rocky Voyager is around 1.6 miles across. New Horizons took advantage of the chance to test some of its instruments, which were not yet completely functional, by speeding by at 63 miles per hour. Following its passage through the asteroid belt, New Horizons targeted Jupiter, the massive gas giant. When the spacecraft arrived in 2007, it took amazing pictures of this magnificent planet as it got closer. Jupiter's enormous gravitational pull on New Horizons during this encounter functioned as a cosmic slingshot, sending it hurtling toward Pluto and accelerating it even farther. The spacecraft's speed increased by an astounding 8,700 miles per hour thanks to this gravity help, cutting 3 years off its travel time to the far-flung dwarf planet. What do you think about the scientists' warnings regarding Oumuamua? Let us know your opinion in the comments below. Like, share, and subscribe for more space content.